Excellent, thank you. And I want to thank everybody who is online right now, considering how early it must be for some of you. So thanks very much for joining me and joining us as we explore Mars together. I want to give you a quick outline of what I plan to talk about. So the Mars Exploration Program Analysis Group, or MEPAG, it's another alphabet soup acronym, but I'll give you an idea of who MEPAG is, what it does, why you should care. And then we'll talk a little bit about what is going on in the Mars Exploration Program right now, how it's paving the way for humans, and what is coming up in the future. And I just want to point out this really lovely picture on the right of my slide, which is a color enhanced image from the high-rise camera of an impact structure that was formed somewhere between February of 2017 and March of 2019, just as a teaser and a highlight of how opportunity driven it is and how discovery driven it is to have these systematic observations of Mars. Who is MEPAG? MEPAG, again, the Mars Exploration Program Analysis Group. And as someone who really hates acronyms, I'm going to point out that I have it on my header. So when I say MEPAG, you won't have to kind of figure it out again. But we are responsible for providing science input that's needed to plan and prioritize the exploration activities at Mars. It's basically community-based. And it's interdisciplinary. We want to get all of the best minds that are interested in all aspects of Mars science and exploration together so that we can, as a community, explore the best ways, the most efficient ways of exploring Mars. So to do that, we update our goals document, and I will give you more on that in just a second. And we are also focused on being responsive to new discoveries and new directions on the basis, excuse me, of the widest possible community outreach. Just to introduce ourselves, this is a list of everyone who's on the steering committee. And I suppose that I should give you an opportunity to know PSI is the Planetary Science Institute. It is a distributed institution. Our headquarters are in Tucson, but we're all over the world. So this kind of remote speaking and remote working is kind of old hat for me. The goals committee, and again, I'll talk about the goals in a minute, are at the bottom. And let me just show you the next slide, which is a picture. It's a little old. There are a couple of people who have rotated off, and we have a couple of vacancies. We're rotating people back on. But I wanted to make sure that everybody appreciated the fact that that list of names is actually a group of people who have smiling faces and lives and are volunteering in this role on the steering committee to forward Mars exploration, essentially in their free time. And so I just want to give a shout out to them and all their hard work. What does MEPAG do? MEPAG maintains the goals document, among many other things. One of the most important things, however, we do is to maintain the goals document. And that sounds very administrative and kind of stuffy, but if you are going to do something as complex as exploring another planet, it is crucial to plan ahead, to think ahead. What are our highest priority goals in exploring Mars? That allows you to let one step build upon the next step, or the next step build upon the previous steps, and so on. It also allows you to be discovery driven. You expect that when you take a step that you're going to learn answers to questions, but you're also going to pose new questions. And so having an overarching document that is essentially consensus by the community saying these are our priorities, this is where we want to go over the long term, allows us to sort of weather the vagaries of differing budgets and differing personnel cycling in and out, priorities of the nation perhaps changing, and so on. So the goals document is actually a really important service that we provide to the Mars community. And we just had a major revision that I'll talk about in just a second. We also, MEPAG also stands up committees as requested by NASA and groups within NASA. And that is important because MEPAG has the capability of basically finding the expertise in the community and putting together the scientific brainpower to address questions as they come up, whether they are, discovery driven or whether there are issues that have come up. We can stand up these committees, which unfortunately often end with analysis group. And so there's NECSAG and ICESAG, and anyway, you get the idea. But these are, again, community volunteers who donate their expertise to help forward the understanding of the science, the current state of the science. So why should you, as a perhaps a Mars scientist, or perhaps just as a member of the public who is interested in science, why should you care about MEPAG? One of the most important reasons is that MEPAG reports directly to several NASA programs, to the NASA directorates, and to the Planetary Science Advisory Committee, yet another acronym. But this PAC is congressionally mandated, and it's one of the ways that Congress gets information about the planetary science, the state of planetary science. So MEPAG and the other AGs, the other analysis groups, report directly to the PAC. So what you have in MEPAG is the combined expertise, the knowledge, and the resources of the Mars community, and that includes both domestic and international. So we welcome participation from any of our colleagues, regardless of where you live, what you look like. We are absolutely non-denominational as far as that goes. We want the best information that we can get, and we want the best consensus that we can reach. This is a slide mostly for our science listeners, but also of interest if any of you are particularly interested in seeing some of these documents. There are links here, and I'm assuming that the slides will be made available. If not, you can always go to mepag.jpl.nasa.gov, and that website will be at the end, and all of these reports are there. So we had 6 months working on the goals document, and just a recent release of that. We had a face-to-face meeting. We have one every year. This one was a virtual face-to-face meeting. That makes your head spin just a little bit, and that was in April. We talked about the decadal survey, the National Academy's decadal survey, which is essentially what should planetary be doing for the next decade. And so there was a great feed in to that. And then we had a virtual meeting recently in June talking about the results of the Mars Architecture Strategy Working Group, or MOSWIG, and I'll give you a little bit more information about that in just a second. Just one moment, please. So recent Mars activities, what's been going on in the, what's the state of Mars right now? You've already heard from Sarah, really, and I mean this, I'm not stretching anything when I say there were heroic efforts that went into launching the Mars 2020 mission, the Perseverance rover. And this was a nearly on-time launch, which is really incredible. And when I say nearly on time, we didn't launch right at the beginning of the window, and that was the only delay, which is absolutely stunning. So I want, again, to give a shout out to all of the engineers and the scientists and everybody who put so much effort in this time of COVID-19, in this, in some cases, very dangerous situations to launch this mission on time. Other recent activities, as I stated, the MEPAG report is in its final stages. What is MEPAG? Well, basically, the Mars community has been focusing on its highest priority science, which is Mars sample return. And you heard some of that from Sarah just a few minutes ago. But what happens parallel to that? And what happens after that? We are success-oriented, and so we are looking at long-term strategies for what happens when those samples come back. What kind of science is going to be driven by what we discover? What kind of science is going to be the highest priority as we move forward? And so, as I said, that report is in its final culminating stages. And then we continue to have basically game-changing discoveries from the vehicles that we have right now orbiting and roving the surface of Mars. And I know there have been recent talks in previous sessions about the assets on the ground. I know you've heard from our project scientist, Abby Freeman, about Curiosity. I want to take just a minute and focus on some of the results that we've been getting from the orbital assets around Mars. This image here you're seeing is just one example of that. This is from the Odyssey spacecraft. You can see subsurface water ice on Mars, some of that at mid-latitudes, which has really profound implications for the paleoclimate of Mars, the current climate of Mars, and potentially how long and where Mars was habitable. Other examples include Mars Reconnaissance orbiters indicating of ancient remnants of Mars northern ice caps that was revealed by orbital sounding radar. And that allows us, again, to map the ancient climate. And that is a time-related sort of science that can only be addressed through these sort of long-lived orbiters. And then MAVEN's mapping of winds in the upper atmosphere, showing really for the first time that the upper and the lower atmospheres are coupled, and thus revealing the global weather system in a really unique way and an important way for how we are going to address future landings. July 2020 was a banner month for Mars exploration. There were 3 launches to Mars. Earlier on in my slide deck, you saw the launch of Perseverance, but we also had the first mission from the United Arab Emirates. That's the HOPE mission. And then China's Tianwen-1, that stands for Questions to Heaven. And this is an artist's conception at the lower end of the slide on the left. On the right, you'll see the ExoMars. That launch was delayed, but it is still planned. It was supposed to go this year. COVID-related delays mean that launch was pushed out, but it is still planned for 2023. And we wish all luck and success to all of those missions, all of our international colleagues with missions who have launched and missions that will soon launch. One of the things I need to give you then is an update on the Mars exploration program, at least from the community side. You might hear this, you would have heard other things from people at the headquarters side. This is kind of what the community is looking at. So the good news for us is that Mars sample return is on track, as you heard in part from Sarah, to bring back these carefully chosen samples of the Martian surface in 2031. We're particularly excited about this because although we do have samples of the Martian surface through Martian meteorites, we do not know, for the most part, their geologic context, and they've been altered by travel through the Earth's atmosphere. And so having very carefully kind of curated in situ, that is, understanding the geologic context of where samples come from, and then having them returned relatively pristine is, we think, going to be a real game changer for Mars science. In 2008, MEPAG, the chair of MEPAG, Jack Mustard, and the MEPAG group put out a report that had 58 high priority science questions for Mars, and over half of them would require sample return, and most of them would be enhanced by sample return. So to understand the early history of Earth, to study the most accessible potential off-Earth abode of life, past or present, and to prepare for human exploration, all of these things can be powerfully addressed by bringing back samples from Mars. And here I have what was reported to MEPAG just a few months ago by Jim Watson, the current architecture, starting with the Mars 2020 rover Perseverance, as you heard, caching well-selected important samples, moving to a sample retriever lander that would have a fetch rover, and then an Earth return orbiter to return those samples to Earth with a partnership with ESA. And again, we're all hoping for staying on time and bringing back those Martian samples in 2031. There is, of course, as always, some bad news. The bad news is not that we have wonderful orbiters around Mars, it's that they are aging, and we are concerned about losing both the science and the technological benefits that we get from those orbital missions. And you can see the heritage relay providers, that just means that not only do missions like Odyssey and Mars Reconnaissance Orbiter, MRO, and MAVEN, and so on, not only do these missions give us some groundbreaking science, as I spoke to earlier, but they also provide relays for the missions that are on the ground. So I am one of the scientists on the Curiosity rover, and we depend on these orbital spacecraft coming overhead so that we can upload the day's information to that spacecraft, and that spacecraft can relay it to Earth. Otherwise, we are dependent upon direct-to-Earth communication, which doesn't happen very often. So the concern here is how we retain the ability to do this very systematic science that allows us to make these important long-term discoveries, as well as continue these relay assets. And the relay burden is only going to increase given the arrival of missions in the next decade, to be launched in the next decade. And so MEPAG is really hoping for a systematic approach to supporting Mars relay requirements, and that includes, you know, the possibility of some innovative solutions like small sats or commercial ventures. We have heard that one of the important things about doing these robotic missions is preparing the way for humans, and I just wanted to address that just for a few minutes. Mars has drawn humans for ages, but just recently there has been a real drive to explore Mars, to better understand Mars, and Mars remains this sort of compelling target for robotic and human exploration for many reasons, and I've just listed a couple of them here. As Sarah alluded to, Mars retains almost in its entirety a record of planetary evolution that is not found in this kind of pristine form anywhere else in the solar system, and that includes Earth. Sarah noted that the oldest rocks on Earth are not as old as the oldest rocks that we see on Mars. So we have the record of a planet that once hosted habitable surface environments similar to Earth's, but through a confluence of events that we are still trying to understand, evolved environmental conditions of less certain habitability. So one thing we can do is look at Mars as the Earth that almost was. And understanding why this is so is crucial to understanding life's origins by deciphering what is required for life to evolve and thrive. And this other reason, all environments on early Earth also existed on early Mars. That is crucial because it makes Mars the most accessible extraterrestrial planet where habitability, right, coexisted with the potential for life to arise. Our drive to explore Mars with robots yields information that will make it easier and safer for humans to go there and live there. And I've just included two ways that I think are important and ways that I feed into. One of them is environmental reconnaissance. The evolution from Mars as a telescopic object to essentially a geologic field site that you can picture yourself being at has occurred really only within about a generation and a half, with the biggest movement occurring with the mobility assets, starting with the Sojourner rover. You can see all of the mobile assets that NASA has launched on these images, these sort of different self-portraits of each of these rovers. Why is that important? Because it tells us about the environment that humans are going to encounter. It raises the number of knowns, and it raises the number of known unknowns. And that's just a fancy way of saying we learn more, and we also learn what questions to ask. Because oftentimes, if you've got 5 little spots, say, on an entire planet, that's not going to tell you half as much, exponentially as much, as being able to drive over bits and pieces of that planet, because it gives you an idea of heterogeneity. How quickly do conditions change? How quickly do features change? How quickly does the composition change? It is only through mobility that we get a real idea of that on the ground. And those are going to be important lessons for us to learn, because it'll help us know what questions to ask before we risk sending people. It also gives us atmospheric data in that global sense that I've already talked about for EDL, entry, descent, and landing, and then short and long-term surface presence. How safe is it to be on the surface? Because of the very, very thin pressure at the surface of Mars with the atmosphere, we're probably not going to be blown away the way we saw in the movie The Martian. However, dust is everywhere. Dust is continually blowing. How is that causing problems for these robots on the surface? And what does that tell us about what kind of problems we will have to encounter and overcome when we send people? And that is just one short example of why it's important to have these robotic reconnaissance missions before to prepare the way for humans to go to Mars. I just want to put up a summary slide that kind of gives you the basic idea of what I've talked about, but I can see the questions in the question field, and so I want to be able to have time for questions. So I'm going to assume that everybody online is capable of reading this last slide. I'll leave it up for just a few minutes, and you can see at the very bottom, go to mepag.jpl.nasa.gov to learn more about the MEPAG group. And I thank you very much, and I'd be happy to take questions.
Hi, Dr. Yingst. My name is Carrie Fay, and I'll be reading your questions for you today. Thank you so much for joining us. That was an incredible presentation. Your first question is from Christopher, and he would like to know, where does crewed exploration fit on the goals?
We have 4 goals in the goals document, 4 broad goals. Understanding life, understanding climate, understanding geology, and then feeding into human exploration. So we have an entire goal that talks about and addresses the priorities step by step for what we need to know before we send humans to Mars. So let me know if that answers your question.
I think it does. That was the shortness of his question, so that's great. The next question comes from Jerry Stone, and he asks, if a Mars sample return craft was in use, ISRU, to make its fuel for the return, then couldn't it come back directly to Earth and not need a rendezvous to Mars orbit? As well as omitting an entire flight, it would be a proof of concept technology demonstrator opportunity?
I would say that, yeah, it certainly would be a good proof of concept. It is, recall that I'm a planetary geologist and not an engineer, so I want to be really careful about everybody understanding what my expertise is. My sense, however, is that with the importance of Mars sample return, this is not necessarily the mission that we want to do a proof of concept study for. Not something so crucial that if it fails, the mission fails. So proof of concept is typically, so for example, the Sojourner rover was sort of a technology demonstration. But the entire mission, driving questions of the Mars Pathfinder mission could be answered without the Sojourner rover. So I think the answer to your question is, could it be done? I think there's a chance that it could be, but because it would be more of a, as you say, a proof of concept or a technology demonstration, that the cruciality, is that a word? The crucial part of the mission in getting the samples back would be put at what I, as a scientist desperate for those samples, would consider kind of an unacceptable risk.
Thank you. The next question is from Graham, and he asks, the Mars Odyssey orbiter is a major data relay satellite, which has been in Mars orbit now for over 18 years. It's critical not to lose any of the scientific data from the landers and rovers. Are there any plans to replace Mars Odyssey soon?
You've hit on an issue that is echoed many times in the findings of our MEPAG meetings. So we have one annual face-to-face meeting every year, except for 2020. And we have a number of virtual meetings every year, and out of most of them come findings. And the finding that you basically stated for Odyssey, but is also true for many of the other orbital assets, is one that continues to show up. We at MEPAG are not aware of a systematic plan to replace or update those orbital assets. But we continue to push for ways to do that so that we A, don't lose the relay capability, and B, don't lose the science. So again, you've hit on all of the really important points that MEPAG has come to consensus with.
Hi, Eileen, this is James. Question for you from Kaj. What instrument that has not yet gone to Mars would you most like to fly on a future mission?
I am a geomorphologist, and I would love to see a camera that is designed to take very high resolution images from very far away. Not just for the science, but for the ability to make operations on the surface for a rover more efficient. Now we have something on Curiosity and Perseverance called the RMI. And the RMI is a part of ChemCam on Curiosity and SuperCam on Perseverance. And that is, at least on Curiosity, it is a black and white fisheye lens camera that is designed to help the laser focus on the correct site. But we have been using it, as scientists are wont to do. Well, golly, can it do this? Can we use it for that? Can we, right? We've been using it for far distance imaging. I would like to see an imager that is specifically designed to do that, so that we can, for example, look a kilometer away and see millimeter or centimeter scale differences. So we don't have to travel to certain places. We can just take pictures, you know, specific spots. and decide while we're doing something else, is that someplace where we want to go? That would make our operations more efficient, but it would also give us some really, really high resolution images of sites that we're never going to make it to, up that embankment or down that crater or whatever. It would greatly increase our reach, our sight. And so if I was in charge, that's the kind of instrument that I would like to see fly next.
Awesome. Thank you so much. I believe that's all the time we have now. Thank you very much for your presentation, and we'll see you on Mars.
Thanks very much. We'll see you on Mars as well.